Well, happy Wednesday, everyone. We are so excited that you are here to join us on our continuation of our Blueprint Labs workshops. And today is a very exciting one because it is the first of many unified AIML workshops. And we have a fantastic guest with us. Adrian is going to be showing us some really cool things on Databricks. So you are going to be all ears to listen in on this great content. We will be recording this workshop, so if you didn't quite get something or if you wanted to take some notes, don't worry about it. We will have it recorded. We will email it to you so that you have that recording and you can share it with your coworkers as well. If we haven't met before, and if you have not joined any of our calls, my name is Ruthie Senanayaka, and I work with Blueprint, headquartered out of the Bellevue, Washington area, but we work in so many different regions. We are a technology solutions company that does everything from strategy to execution. So if you have more questions about what Blueprint is and what we do, go check out our website. It is bpcs.com. You can also email us at info@bpcs.com for more information. Couple of housekeeping tips. If you have any questions, we highly encourage that. We will be taking all of the questions at the end of the workshop, but you can add them at any point in time in our Q&A section. You can add them anonymously, or you can add your name with it, whatever works best for you. And just, you can stay on the call to ask those questions, but let's say you have to drop off, no worries, you can email us or connect with us on social media as well. Be sure to follow us on social media to find out when our next workshops are coming up. We do have an awesome one next week, so you can register for that one by going to bpcs.com/events as well. But without further ado, I will hand it over to Adrian.
Sure thing. All right, thank you, Ruthie, for the introduction. So hello, everybody, and welcome to our workshop on Unified AI with Databricks. So today we're going to be going through about, let me do a quick introduction. So if she didn't get it clear, I'm Adrian Tullock. Sorry about that. I'm a data scientist with Blueprint. And today we're going to be going through about 10 or so notebooks looking at the major components of ML operations. So if it sounds like what you signed up for, you're in the right place. If that's not what you signed up for, you're probably still in the right place, but we'll help you figure that out just a little bit here. So we're going to go ahead and make sure that everyone has a good view of the screen. And we're going to go ahead and jump right into things. So for the first thing we want to do is give everyone a bit of a context for what we're going to cover. So we're going to start off with a definition of ML ops and then tell you about the problem that we're going to be solving. So we're going to come in, first of all, ML ops, what exactly is it, right? So ML ops is portmanteau for machine learning operations. So for those of you that are familiar with DevOps, you can think of it as DevOps for a machine learning model. So in place of trying to move, say, application code to production, your carried load is now instead a machine learning model. Now, ML ops in practice is more of a set of guidelines than being something that's very prescriptive, right? So I believe the two images that we're looking at here will give you a good idea of, make sure we have a question coming in. Okay, that's not anything important, right? So the images below kind of give you an idea of how to think about ML ops. So the first one on the left here shows you that ML ops is more of a cycle than a life cycle. So you will continuously iterate through the steps of ML ops as long as you're continuing to use machine learning to bring value to your organization. And then on the right, you have a bit more of a step-by-step look at what ML ops is for you. So you'll start off with your EA phase, exploratory data analysis, before you go into the cleaning of your data, doing feature engineering, and that'll be all for your model tuning and model training phase. So once you've finished up that step and you determine which model is going to be best for what you're trying to do, you move on to the model deployment and monitoring phase. Now, and for organizations that mature themselves a bit further, you can eventually reach the stage of automating the retraining of your models to make sure it stays fresh and drift doesn't start to affect the performance of your deployed models. So that tells us a bit about the what ML ops is, but we want to get into now the why, right? Because implementing ML ops will take dedication and it will take effort, time. So first argument I would put out there is I would argue that if your organization is not employing ML ops, then machine learning is simply not a part of your business. Full stop, right? At best, you have a research project which can become a machine learning operations, but you must first put in the investments to make sure you have things up and running. So you can implement ML ops with an individual, or you can do it with a team. And you get the most benefits for you can expand it out to a team. And you'll see gains in the realms of efficiency, scalability, and risk reduction. So another way of listening to that is you will be able to have your team deploy and develop high quality models faster. They will have better quality tracking for the process, and they will have a framework in place, I would say, for checking all of your models, whether they're being in development or in production. So that'll cover a bit of the why. Now, the problem we're going to solve today, so everyone has context, will be the binary classification of articles versus advertisements. So we're going to have a data set that will consist of labeled advertisements and articles, and the goal to be able to have a machine look at these and be able to tell the difference so that we could bypass ads in our email inboxes or our news feeds or anywhere else that this AI might be potentially useful so that we hopefully will not have to. So since we're talking about AI and ML, then we have to start off with the ever valuable data, right? So first thing we want to do is look at the data set that we're going to be working with. So we're going to come in, pull in our data set and see that it's pretty straightforward. We have, as we mentioned, our titles, their labels, some date metadata, and individual identifiers. Now, we'll take a quick pause here and note that this data could have come from anywhere. So we could have pulled this in from a set of CSV files from the storage account somewhere. We could have pulled this data in from a Snowflake table elsewhere. The bottom line is that wherever your data currently sits, there's a way to pull it into Databricks and get the benefits of the environment's ML operations. So even if your organization is not in a position to move all of your data operations over into Databricks, that is not a hindrance to you being able to gain benefit here. So with that being said, we're going to pull our data set in, and it may not look like we have too much work with, but this is where the expertise of a data scientist will come into play. So we're going to perform some NLP, some natural language processing on this data set to be able to extract the features that we want to use for machine learning. So specifically, we're going to tokenize and explode these titles and then get the position, the POS, aka part of speech, version of each one of these words, and then lemmatize them as well. And that will give us our features. Now, if we take a look, we have our new data set, we have our parts of speech recorded, etc. But this process took us about 10 minutes to perform. So anytime we want to come back and maybe iterate on a model or train a new set of features or whatever, we do not want to have to repeat this process over and over again. So we will want to persist this data inside of a feature store. Now, we're not going to cover feature store too much in depth right now. That'll be for just a little bit later, but it'll be enough for you now to know that we can persist this data using feature store. And all we needed to provide was a name for the feature store here, a unique identifier column, the schema for the data, and of course, the data frame itself. So now that we have our data and it's persisted, you want to get into the exploratory phase. Now, this is the first part of our ML ops diagram that we saw a little bit earlier. Now, this phase is quite important because it'll give you an idea of what your data looks like. And it's important for data scientists to have that context. And actually, depending on how your exploratory phase goes, it could be the very time-saving step that informs you that your data is not fit for modeling to begin with. But proceeding past that, there are a few things any data scientists want to know before they train a model, such as, do we have enough data, right? Are there any notable correlations or class imbalances? Do we have data quality issues, and how much work will it take to address them, right? What features do we have that are useful? What features will we need to engineer? Is there enough variation, et cetera, et cetera? So once you've gone through all these steps and these questions, when you've completed your EDA, at bare minimum, you would like to have a profile of your data and a set of visualizations to help communicate its essential shape. And luckily for us, Databricks has tools to help us with each one of these processes. So as of runtime 9.1, Databricks has installed a profile that you can access pretty easily just by having your data frame and telling it to do the profile for you. It will take each one of your columns, do a profile based on its data type. And outside of that, it doesn't take much work to get it through, but mileage will vary when it comes to this profiling tools, as we're going to see before. So because some cases are much more easily gain benefit from than others. So we're going to return to our feature store, use the read table function. Again, more on feature store later, but all we needed was that to pull in our feature set, and we can look at the profile that Databricks gives us. So it's breaking our columns into integer and string types, and we'll focus on just the integers for now. So we'll see at the top, we have our summary statistics. We can look at a histogram of our features, so we can even change it into a quantile format if that suits the information that we're looking for. If we scroll down to just the bottom of here, we'll see that it also qualified our read date as an integer, and it's giving us our min and max dates there. So that's useful information to have. Moving over to the string features, we can see what percentage of values are missing, how many are unique, and what the top ones are as far as your frequency goes. Now, for us, what may not be the most useful is that the features that we generated, they are more so categoricals than integers. So this type of data may not be super useful to us. And so for scenarios where the profile that you're offered may not be the best that you have, you could be well served. You'll be well served to potentially have another set of profiling tools that fit into your standardized profiling process within your team. So the one that we're going to demonstrate here is specifically built to leverage the Delta Lake. So we'll be able to profile our data, store the results in the table, and then retrieve them again at any point to get a look at them and do what we need to look at them and not have to rerun this process all over again. So as mentioned before, our features are integers, so we would like to see them looked at as categorical. So one feature in this tool is that it will not alter our data frame, but we can tell it to process each one of these features in the profiler as a Boolean. So we will instantiate the tool, pass the data that we care about, and this will be telling us that we told it to write the summaries, there were no issues, and then we get into using the other tool here to pull in that summary, and we can look at how it's broken down in these tables below. So we'll have a numeric summary, a string summary, a bool summary, distinct values, and unique string values generated from the tool that we built. And we can go through all those tables, look at the information, and take a couple of findings away in our profile in summary. So we know that there are no null values. That is important to know. And due to how we generated our features, it'll take the shape of a sparse matrix. Our advertisements will take -1 and 1. We can tell by this average leading negative that it leans forward to add to stories, articles versus advertisements. And we have 20,000 distinct words and 16,000 once we turn those words into lemmatized versions of themselves. Now, looking at our breakdown of parts of speech, nouns are the most heavily found in the distribution, followed by verbs. So noun being heavy would make it a potentially good candidate as a base case for our model, and interjections being relatively low will inform us that this column will be very heavily skewed towards 0. So that will be worth knowing. We'll proceed down a bit further. Now that we have our profile in place, we need to have visualizations. And Databricks can help you build those rather easily as well. All it needs is the context to your data frame, which, lucky for us, we pulled in not too long ago. So we have a couple of different tabs here. The first one will show us that our data set leans heavily towards articles versus advertisements, almost 3-to-1. So that's worth knowing. We'll look at our different parts of speech, which we pulled from our tables. Verbs and nouns are dominant here. That was already known. Little fun with the word cloud, but we can see what the parts of speech are. which lemmatized words show up the most. And then we'll have this valuable piece of information, which will help us understand if I'm looking at advertisements or articles, which parts of speech seem to incline us towards one or the other. So symbols and numerals seem to be much more heavily used when it comes to advertisement titles versus articles. Everything else has a different slant to it. And we can't forget to look at the time analysis of our data with visualizations as well. The data set runs from about November to June. We can see how many stories were added by month, and we can see easily that December has the highest number, and that's what this visualization shows us here. And since it's interactive, we can say, well, if we take this month out, how does the remainder of our data break down here? And we see that January and March and then February are the next highest when it comes to proportions. So that'll give us a good look at our data. Now that we have an understanding of it, we'll care to move into doing some actual modeling. So that's the step we'll take a look at next. Now, on this notebook, we're going to be looking at AutoML within Databricks. And AutoML is essentially a lot what it sounds like. So it'll help you automatically apply machine learning to your data set. So you simply provide it with the data set and the prediction target, and AutoML will get to work preparing your data and then training and tuning multiple models and then leaving records of those for you to look into later. Currently, the type of problems that it can solve are classification, regression, and forecasting using these model frameworks that we see here. So we're going to look through how to actually set up an AutoML experiment here. So once you've gone to the experiments page, the AutoML experiments page here, you'll be able to do your configuration. But before you can even get to there, you will need to have a Databricks runtime with an ML on it running already. So to identify those when you're setting up your compute cluster, you will look for the ones that have ML in the name. That will imply to you that you have found one that will run machine learning. So we come to new, we find our AutoML experiment, and we attach our cluster. And then from here, we set up our experiment across 3 configuration areas. Your experiment configuration, advanced configuration, which is optional, and schema. So we have a shot of that here. If you can see the full screen, once we've attached our cluster, we're going to pursue a classification problem. We're going to use the feature store data that we use, and the advertisement column is what we want to do our predictions on. Bypass here. Oh, and we're naming it here. This name will be relevant a bit later. Now, in the advanced configuration, we can choose which evaluation metric to prioritize. Given our frameworks, we want to do our train test split based on dates, and we're going to give it a timeout of 2 hours. Now, it's worth noting here that even though we set 2 hours, if AutoML detects that we are no longer getting improvements out of the model that we are generating, it will retire the experiment early for us. And then next we'll move over here into the schema. So here is the list of the columns that were generated as features for us. And we can decide which features to include in the model, which ones to extract, or should say exempt, I should say. And if there happen to be any null values within the data set, you can choose imputation rules for the remainder of those columns. So once we give it its 2 hours or whatever the timeline that it takes, AutoML will complete and it will give you a result screen. Now, on that result screen, there are 3 primary objects that AutoML will supply you with. It will recommend a notebook which has the best model as chosen by your chosen evaluation metric, and an exploration notebook which will look at the data similar to a bit of a profile that we did earlier. So we'll get a chance to compare that just a little bit. And every other model that was trained that was not ideal, if you care to look into those, there will be a table section just beneath that with metrics and other things to help you evaluate which one you may want to look at, if not the best model that was recommended to you. And then finally, at the end of every experimental run, a table of warnings will be supplied to you, so it can tell you what it found in the process. So we're going to go through a few of these just to see what value we've gotten out of it. So with the first one, it's going to see that we have columns that is going to categorize. They're going to look at them as categorical columns. And note that this will be relevant when we get to our training notebooks. And we'll talk more about that when we get there. It's also going to say that it's going to profile a subset of our data, not the entire thing, for concern of maybe running out of memory and breaking. So it's very concerned with making sure the process does not break mid-running AutoML. It's found a high level of cardinality with our lemmatized word column, and it's going to perform feature hashing on it. Now that is key because our words are string values, which you cannot perform reliable math on. So the fact that it caught that and transformed them instead of crashing is valuable. And then it also detected that our interjections are highly skewed, and it makes note of that. So while we have a good amount of praise for what AutoML can do, there is a word of caution for the wise that needs to be thrown here. So AI tools are built to be good at what they do. However, they are not omniscient, right? So LLMs will hallucinate because they do not have encyclopedic knowledge. Similarly, AutoML itself is not a trained data scientist. So you will need specialized skills and knowledge to be able to critique its work to make sure you are getting the optimal value out of it. So given what AutoML provides, we're going to be looking at these just a bit here. And we will start with the exploration notebook. So we were already pre-warned that our data would be filtered. And so in that event, we can come on down here and notice that on line 6, it tells us all we need to do is comment out this line, and we can rerun the notebook to get a full contexted profile. So we do that and rerun it. Also worth noting is that AutoML uses pandas profiling for its profiling tool. Now, this is relevant because pandas profiling as a library was deprecated earlier in 2023. So I would expect probably some changes to the data exploration tool by 2024, if not somewhat sooner. But that being said, it's a pretty useful tool. So once again, we're being notified of the semantic type that was detected. It will notice in the training notebooks, these will be encoded as categorical features. However, what's interesting is that it does not actually profile them as categorical features inside the profiler. So whether that is desirable or an issue will be up to the user of the tool to decide. So getting into the actual profile report that it generates, we have our typical distribution information shown here, and it even gives us a couple of familiar alerts right at the top. So it's picked up on the high cardinality of our lemmatized words and the interjection column being highly skewed. Then it goes further into breaking down each column with a different set of information based on its data type. So lemmatized word is a categorical. We have our decent bit of information there. But if we dive a bit deeper into the details, we can see statistical lengths associated with it, different distinct characters, and each one of these next ones will give you different frequency distributions by categories, words, and characters. And some even have further deep dives below that. So that can be pretty cool to dive into. Then we'll look at midway, which is a real number. So we have our basic summary statistics here. If we dive into the details even further, we can look at our quantiles, interesting things such as kurtosis, if that's your thing. We have a histogram and other ways of breaking down the values, which can get pretty interesting when you have more than just a couple of numbers here. So, and not to be finished, it does this for every single column in your data set. And then once you get beyond that, you'll have interaction plots, correlations, things about missing values, matrices, etc. So all in all, it's a pretty useful profiling tool. And if this seems appealing to you, this can very well fit into your organization's standardized profiling practices. And by running AutoML, you essentially get a template to work with this basically for free. So that could be an unknown or I should say an unforeseen benefit potentially of using AutoML. But beyond the profiling, now we want to get into the modeling portion of AutoML. So whereas an AutoML experiment would give you one exploration notebook per experiment, you'll get an individual training notebook for every model that it creates. And what we're looking at here is an example of one such notebook. Now, it's useful that you can come in here and look at the transformations that are done, the hyperparameters that were chosen, and et cetera, because as a trained data scientist, you may not agree with every choice that AutoML makes, You can easily come here and make those adjustments. So we'll look at a few of those quickly here. So not to have to continue scrolling, the summary of them right here at the top. So we noticed that we used read date to do our train test split, and it ended up including the read date as a feature in the model. This was not desired. So we have to manually go in, remove that feature, and then rerun this notebook. So we also noted that now would probably be a good base case for us. We selected that and omitted it from the model, but AutoML had its own thoughts about it and eliminated another column while it was doing one-hot encoding. So we need to address that to pull that context back in. So we also noted earlier in our profiling there were no null values, but as a matter of crossing its T's and dotting its I's, it attempted to do the imputation step anyway. We can manually remove this to save some time in processing. Once again, we'll give it kudos for converting our string columns into a compatible format via feature hashing. And then lastly, it has incorporated into it the ability to run the notebook over again and turn on SHAP, which is an ability to have that some explainability to your models. So we'll cover that here. So just as a quick example, we're seeing here, we commented out this, drop the time column to have that context there, and more changes like that will show up as we go through about the transformations. We want to get down to our hyperparameters. So here in our hyperparameters, we can see which ones were chosen by AutoML. And you can, as a data scientist, come in here and expand the search space if you want to optimize over a particular set. But AutoML will not do this inside of any particular notebook. So that option will be left up to someone who wants to come in and tinker with it a bit more on reruns of the notebook. Now we're going to scroll past our trials. And as we mentioned, SHAP by default is disabled. You have to come down to this line, set this flag to true, and then you can rerun it and it will give you a SHAP chart here. So those who are not familiar with SHAP, it is a method to try to make your models more explainable by taking all the features that you're using and try to rank them for how important they are for predictability. So this one is telling us that lemmatized word is the most important feature for both of our categories that we're trying to predict on, and symbol and proper noun, etc., are more important as you progress from there. And then just below at the end, it'll give you some tips on how to perform inference with your model. And then we'll have some visualizations and some results for what was done on your validation set. So all in all, AutoML is a pretty useful tool. It's great for getting your machine learning projects off the ground, but you will need specialized skills and knowledge to be able to get the optimal value out of it. So I believe all that's worth knowing, but if it suits you, I would recommend giving it a try. So outside of auto ML, there's also the manual ML process, and Databricks is equipped to help us with these steps as well. So we're going to go through about 2 notebooks looking at procedural training and testing of models, and we're going to do it in about 2 frameworks. So first, we're going to look at the Databricks feature store capabilities, and then we'll transition that over to MLflow, which is another popular framework for performing machine learning. So Databricks feature store. What is a feature store? Quick and dirty of it is a repository for your machine learning features. So thinking of it as a repository will probably be the quickest way to get intuition of it. So as we saw before, we did some featureization on our data, persisted it in a feature store, and while it sits there in branching format, different people can go to that feature store, train new machine learning models on it, build their own features off of that feature store, et cetera, all without affecting anyone else's work. So the benefits are also beyond that, because within Databricks, feature store also has a UI. Now, this UI is more functional than Flare, but still there's a bit of value here. So for this one, we're going to see the name of the feature store and the name that we gave it, the source from which we generated it from, which for us was the previous feature store. We can see the notebook that generated the feature store that we're looking at, and we have 10,000 or 1,000 or so features here, but you can go through each one and see its data type or where it's being used, etc. So you will recall that we decided not to use noun as one of our features in our previous model, but Midway was. So you can easily come here, see what features are being used, and then follow that trail to other pieces of information that you may be looking for. And then the third part of Databricks Feature Store is this programmability. So a lot of things can be done with it via code. This is just a quick table of some of the features, the methods that we'll be using, but we'll get right into that below. So within the library Databricks.Feature Store, that is where we will find the Feature Store client and the Feature Store lookup methods. So we're going to come in and Feature Store.read table, and all we need is a feature store name, and that is how we pull in any previous feature stores that we've created. And then we're going to move on to doing some feature hashing. Recall that AutoML took care of this step for us. We're going to do it ourselves, and this is all going to be processed in Spark, which is native to Databricks. And we're also going to notice that this process itself took 5 minutes on the cluster that we ran. So we do not want to have to repeat this step over and over again. So we'll take this new feature set of about 1,000+ fields in it, and we're going to create a feature store for that. We've seen this before. You're going to pass it the name, the primary key, the features, the feature schema, and then the data frame itself. So now we're going to move on to actually creating our training set from our feature store. We need to pull those features in using feature lookup, and all that's required to get those out is the name of your feature store and the primary key. Here we're just annotating which columns we do not want to include in the final set, and then we'll use feature store's create training set method to do the join on our inference data frame, which holds our prediction values, the model features which we just pulled in, the feature target, and the columns that we want to exclude. And it'll take care of all the joins and drops for us if we use this method. All that's left for us at this point is to split our test and train sets, and then we can get into our modeling, which in this instance will be a random forest. So we're going to provide a name for our model, start an ML flow run, and then within here, you'll see a lot of your typical machine learning fare before we decide to use the feature store client to log the model. So you'll pass it the model, an artifact path, the flavor, and the training set that you use. And if you opt to pass it a registered model name, it will take the additional step of registering your model for you. If you omit this, it will just log it and not do the actual registration step. That's a nice feature to be able to have, to remove one extra step for you. And once your model is registered, this is just some example code of how to run a batch inference on your data with that registered model. So Feature Store has been able to assist us in just about every single step of this machine learning process, but by far one of the biggest uses for Feature Store is just creating a feature set and persisting it and not having to create it over and over again. And if you want to use it for nothing more but that, you'll be fine. You can also use another framework, ML Flow, to do your machine learning procedures, and we're going to show that in this notebook here. So the flow of this will be very similar to the previous notebook, but using ML Flow. And we'll talk about why that's a little special. So ML Flow is its own open source platform for managing machine learning. And it's probably most popular for its tracking, model registry, and model serving functionalities. But within Databricks provides a fully managed version of ML Flow inside of its workspace, and it's integrated pretty well. So for those of you familiar with it, you may see some similar aspects of traditional ML Flow within certain parts of the UI. Now, in general, you can jump back and forth between the feature store client methods and the ML Flow client methods almost line for line. So you can choose whichever one is most comfortable for your organization. And we're going to outline that with a couple of specific lines. So in the previous notebook, we did the read table function method. That was essentially going to the feature store table and pulling in that information. You can do that directly yourself. It's just in a Delta table. If you want to create the training set, all the joins and drops were done within this one function call. You will have to handle those joins and drops yourself if you prefer the more manual process, if you do it without the feature store client. You only needed the log model function and register name to log and register your model with the feature store client. That'll take about 2 or 3 calls without it. So you'll need to log your model, evaluate it, and then a separate call once again to register it. And then performing batch inference. So Feature Store has the score batch method. Without that, you will need to actually load your model in or with the URI and then provide it with the data set you want to perform inference on. So going through here, a lot of similarities. We're doing everything manually that we just went over, except once again, we want to persist the features that we generated to do our machine learning on. So we're going to persist that with the feature store and not have to touch the feature store again for the rest of this notebook. So our manual joins and drops and etc. And then we move into the ML flow flavor of actually logging and training our model. So we're going to do like GBM. We want to instantiate the ML flow client, name a few of our training parameters, and start an ML flow run. So once again, more ML flow machine learning fair. One of the things that ML flow is popular for is its ability to log metrics as you so choose and keep the process going. That's what these lines are here if you have not seen them before. And then we're going to log our model and then evaluate it to make sure all the metrics are added to it. And we're going to come down here and register it. So there are 3 calls to get that entire process done. And then we have 2 blocks down here, which are just showing how to do batch inference with your model with a Pandas data frame or a Spark data frame. So that's all we have to offer here. So whether you're doing the ML flow or the Databricks feature store flavor of doing these things, you really can't go wrong. There's not a whole lot that needs to be changed if you want to test one out or jump between the 2. So if it works best for your organization, by all means, go with that and feel free to experiment. But the feature store is the one thing that will be able to persist your features that ML flow cannot do. So up to this point, whenever we wanted to register a model, we've done that via lines of code. Now within Databricks, there is also a way to do that with the user interface. And that user interface is tied to the experiments UI. So we'll be covering both of those here. So starting out, you'll notice we have 4 rows here. Now we trained models in 4A and 4B, the previous 2 notebooks, and those models are registered under the names of those notebooks. And then also recall, we took AutoML, we took one of their notebooks, tuned it and fixed a couple of things and retrained that. That is this instance of that experiment here. And then we have the AutoML experiment that we ran. And every model that was generated will be stored under the name of the experiment that we gave. So if we select that one there in the orange block, we'll be taken to the table view inside of experiments. So if we start over on the right side of our table, where we can see the tags, parameters, and metrics associated with each one of these models. And you can resize these columns, you can alter what they are, you can filter and sort on them as well. As you proceed further right for each model, you'll see the auto-generated names. And so if names like learned, lamb, and debonair snake do not seem to match your naming standards, or they're just not informative, yes, you can change these names to something more vanilla like candidate 2. You can also delete any models that you don't find particularly useful and decide what's going to be valuable. Now, if you checkbox more than one of these models, you will be able to compare them inside of the comparison screen. So you'll be able to scramble a few different types of visualizations, scatter and backplot are some of the options shown here, and also compare the run details, parameters, and metrics side by side. But also if we go to the chart view, you will find a lot of similar functionality that's in the comparison view, but it's better geared towards comparing a large numbers of models using visualizations. So once you've gone through all this information and you found out the model of choice that you want to actually run with, you can come back in here and pick one of your experiments and register one of these models in the UI. So you'll click one, it will be taken to that runs artifact page, and then you'll locate the register model button, likely around the top right corner, and click that. That will open up a register model window. You simply provide a name for that model, you hit register, and here in our registered models table, we now have version 1 of that model. So that's pretty much all you need to do to get that step done. So now that we have a model ready, Now we want to look at the deployment phase. And model deployment is not so much the what, but the how. That's where the substance is. It's how you do it, right? And so for every organization, you're going to have to maybe make some tweaks to the process about how it's going to work for you. But at the end of the day, you're always going to be primarily either deploying code or you're going to be deploying models. And there are trade-offs depending on which one you go with. So there are some things you'll be having conversations about what's going to fit better. So as one trade-off example, you may be able to go the deploy model route because it's cheaper. You don't need as many training runs to get the thing moved up to production. However, you may experience a bit of a struggle in trying to automate that process cleanly and effectively. It's an example of one trade-off. So whichever route your organization goes, just make sure your entire team is in alignment with it, because things otherwise can get very messy very fast if things are not standardized. Now, wrapping back around to the model that we just registered in the last notebook, we want to figure out how to deploy that and get that ready for production. So you'll come to your registered models. We're going to select the one here boxed in orange, and that will take you to that registered models page. Now you'll come to the stage drop down, and you can promote it to staging or production, whichever stage that you find yourself at, to move it along the process. And you will add notes to the activities log to help you stay informed about what steps were taken and why as your model's lifespan continues. And this can also be done programmatically in the ML flow client. I thought that might be worth mentioning. And then once you have it ready, then you are ready to position your model for inference. And you have three options for how to do that. So you have batch, streaming, and real time. Batch and streaming will have very similar outputs depending on which one you pick. Both will generate a notebook within Databricks that will give you the step-by-step of how to perform inference on your model. The primary difference in these results will be that the streaming version will use Delta Live tables. And batch inference, we've seen examples how to do that pretty much already. So the steps that will give you that you'll be provided in those notebooks, what we have below here are just very condensed versions of what those steps will look like. And DLT is the Delta Live table, a library that the streaming version of it will use. Now, real-time inference is the different, albeit still friendly monster that will expose your ML flow machine learning model as a REST API endpoint. So these endpoints operate as dedicated, scalable serverless compute that will allow you to execute over 3,000 queries, low latency queries per second. And even better, they're very simple to get set up for your model. So you will come to the serving endpoint, the serving option inside of your UI, and you will simply need to provide a serving endpoint name, the model and the version of it you want to use, and the compute and the utility to create the endpoint. And you will have one ready to start running inference on. All you will need to do is to do a HTTP post request to get at your model and perform inference on it. And also, we should note that you will need a Databricks access token to make sure you can verify who's accessing this model or not. And you can also add multiple models to an endpoint once it is up and running. And you can continue to return to this page to track how the endpoint is doing. So metrics such as your request rate, latency, and CPU use can be tracked over the time, over the lifetime of your model. And as we mentioned before, you need an HTTP post request to be able to perform inference on your model. So pretty straightforward. If you want to do that, either one of these steps can work. It just depends on what your particular use case is. But once we have our models trained, we select the one that's up and running, be it staging or production. Now we want to monitor the model to make sure it will continue to give us business value. So we'll have to get a little bit conceptual here, but hopefully this part will not be any less useful because of it. So we need to talk about drift. So drift, in a nutshell, is the natural decay of your model's predictive power. And that can happen for a few different reasons. And you need to be aware of them if you want to hope to capture them. So we have model drift and we have data drift. So it's probably easy to think about model drift as things that are occurring within the problem space in which your machine learning model is operating in. So if you're used to predicting local gasoline demand within one type of economy, but then electric vehicles start to hit the road a lot more, it may throw off your model's ability to predict what your demand was, and you had no control over that, and nothing needed to change for your particular model. Or you may have a supplier which you reliably depend on certain textiles from overseas, and now they've shifted to a war economy. So you can no longer use that supplier as a consistent, reliable partner in getting your supplies. So that will affect your business as well. Now, data drift leans more into your data itself or the subjects of the data. So changes in the distribution over time. So you may be trailing inside of your application, your customers' purchasing habits, making recommendations, but the purchasing habits are starting to change for one reason or another over time. So that'll degrade your engine because the distributions are changing. Similarly, as customers engage with newer technology or begin to shift their behaviors, that will throw off your ability to actually capture what needs to be recommended. So these are just a couple of ways that your model's accuracy can start to erode without anything actually being wrong with your model. So some potential ways of addressing that would be to retrain your model, do some new featureization on it, or maybe replace your model entirely, which can capture the problem space in which you're working in quite a bit better. Now, monitoring for drift is, there are a number of statistical options for being able to do that. But a common approach is to have a chosen metric and to evaluate that against a certain threshold such that you will know when to pay attention to certain things. So we're going to use our advertisement classification machine learning model as an example here. So we are going to see that as our data set increase in size over time to about, from about 300,000 to about 800,000, we're going to also track how the distribution of our advertisements to articles, as well as our parts of speech, end up changing over time. And the less movement that you see, the better, right? So if we cared about capturing a 5% threshold, we can run it and say cumulatively nothing has exceeded that, and we're fine. But for argument's sake, if you wanted to get a little more granular and say, if anything crosses 1%, let me know. And just capture that we've seen an increase in ad percentages by 1.3% over that time period. Now, since we can get these values out, it would not be much for us to set up, orchestrate some jobs, create some tables, record this information, and do what we need to do to make sure we're tracking this correctly. However, if you have the option, I would recommend a more advanced tool to perform that job, and that would be Databricks SQL. So only premium tier accounts have access to Databricks SQL. But if you do, within it, you will be able to create customizable dashboards that will update with your data as it changes. If you see, we had our calculation threshold at 5%. If we want to now monitor that every day, we can set a trigger up for it in Databricks SQL, and it will send us a notification in email or Slack. So we'll know when to go and look at the data and find out what's going on there. And if there are certain dashboards created where you don't want just anyone seeing everything, you can do role-level based permissions within Databricks SQL to manage privileged information. So we don't have it ready to show on the sake of time, but this is kind of a view of what an example dashboard could look like inside Databricks SQL. So if anything has been useful up to this point, hopefully you can kind of take a word a bit on that, but for the sake of time, that'll be most of what we have to show today. So we thank everyone for their time. If we have time on the clock for questions, I will allow Ruthie to take those, and do pass us feedback if you find anything in here that was useful, or if you want us to add anything. So I will pass it back to Ruthie now. Thank everyone for their time.
Thank you so much, Adrian, for all of that awesome information. Does anyone have any questions? I haven't seen anything come through the Q&A, but I'll just give everyone a moment to add in anything there. And in the meantime, I will add a link to our next workshop that we have next week. It is on modern infrastructure and security on Databricks. So I'm going to add this into the chat. If anyone would like to register for that, feel free to hop on there and just click the register now button. And we'd love to see you on there next week. no questions in at the moment, so we will wrap it up, but we are definitely available to answer any questions that come in later on. You can email them to info@bpcs.com. Once again, we will be sharing this recording via email to everyone on the call. We will also be posting it on our social media, so be sure to follow us on there. And I want to say a big thank you to Adrian for doing this entire workshop for us. It's been extremely helpful, and we hope to see you all on the next one. So thank you all for joining, and have an awesome rest of your Wednesday.
Thank you.
Bye, everyone.